Hey everyone, thanks for joining us. Thanks, Lindsay. The webinar, as she mentioned, is talking about BI in the cloud. And the question we wanted to ask was, should you make the jump? And so first I want to introduce the concept of why BI exists. And if you guys are all BI professionals, you've been doing this a long time, sometimes it's just good to refocus our attention on why we're here and what we do. And the first thing I want to draw our attention to when thinking about this question is the reason we exist is that because questions about business span multiple areas. If we truly want to understand what's going on, we'll have to pull in information from sales, from our marketing system, and possibly from IT, just as one example. So in BI, our goal should be to bring all of this data together in a way where we can truly understand what's happening in our business. Think about if you're trying to navigate your path across a landscape. It'd be really advantageous if you could just kind of zoom out or come to a higher elevation and see what the road ahead may look like. And inside each one of these systems, there could also be multiple systems. You know, no longer is it just, sales operates off of a single platform in marketing and IT. We all have many different systems that actually encompass all of our processes. So let's take a look at an example. Let's start with a marketing example. Here's a simple one where a lot of companies use these, combination of platforms to run their marketing engine. Salesforce handles a lot of the campaigns, Pardot does a lot of the kind of email stuff, and then you have all these external sources as well, like Google Analytics capturing what's happening on your website, Facebook and Twitter giving you that kind of social world of what's happening, what are people saying about you out there. So if we wanted to, follow our traditional process here about how to pull this data together and analyze it, it would look something like this. We would have all of our data sources on one side kind of flowing into this big data warehouse, almost like a Costco of data. And then out of that, we'd have all different kinds of analyses. Those could be charts and dashboards that people can interact with. It could be email reports that are being spit out. It could be, selling mail lists or something like that if we're kind of a vendor of that sort. And we're providing access to this in a way that makes it simple and easy to answer those questions that span multiple areas. So what is the challenge with this? Well, the challenge is that it's really expensive. This data warehouse itself could be a huge set of servers that cost a lot of money to set up, and we'll take a look at kind of the more detailed aspect of that in a second, as well as all the outputs need to be handled by a bunch of hardware and a bunch of machines. Whereas, these other ones on our left are actually already in the cloud. Something interesting about this example here is that all these data sources are kind of living external to our network, to our on-premise systems. So when we think about what does it take, it's kind of the trifecta of cost here. There's people, time, and money are all required when it comes to doing a traditional business intelligence implementation. And the traditional one, just from the people aspect, will need engineers, admins, networking people, project managers, and hopefully analysts to actually get some value out of it. Each one of these roles are hard sought after. It's hard to find good people in each one of these. They're also generally very expensive. And in this market, if you guys have been trying to hire people like we have been, you know how difficult it can be. So imagine it takes all of these people to really get this up and running. From a time aspect, we have a much different challenge. The typical project on an on-premise business intelligence implementation, looking at like a data mart for marketing, let's say, is our example here, could take anywhere from 6 to 9 months. Hopefully you guys are laughing at that because you're so much better than that, but I'll just say from my experience, it's 6 to 9 months is a reasonable amount of time to roll out a new data mart or a new system like this. So if you think about that, from the time that somebody requests it in Q1, we have 2 more quarters that have actually already passed or could have passed before they actually get what they asked for. So what in turn happens is our needs start out looking like one thing, and by the time that we actually deliver it, the needs have totally changed. So there's a disconnect there. And all along the way, we've spent a ton of money. Servers can range from 40K upwards of 500K or more, depending on the size of your cluster and the quality of your hardware. The storage similarly has a big wide range, in a distributed environment with something like a Hadoop or one of the more big data systems. They've kind of really made themselves successful by running on commodity hardware, whereas some of the older systems require super fast disks like solid state drives, which can be very expensive. Each time we do this, we're generally using a vendor platform, and so with that becomes a big support contract. In fact, I have a funny example. I was consulting at a company maybe about 10 years ago, and we were paying $620,000 a year to the vendor to not upgrade to the latest version of the software, which was cloud-based, because we were too afraid of it. And we're also afraid that it had taken us so long to get to this point with this implementation that we didn't want to go through that pain again. It was just so long and painstaking that we'd rather pay, above $500,000 a year just to keep things the way they were. And thankfully things have changed. And to sum it up, there's a better way. But we need to, taking a note from Apple, think different. So, the answer for a lot of us, or the thing we're going to explore today, is should we go to the cloud? Is the cloud an answer? Well, I'm going to present to you now the options of how we could do this. Think about our example. We have our data sources, which are actually all living in the cloud already, and those data sources can flow into a cloud data warehouse. We don't have to host that ourselves. And then from there, the actual outputs that we produce can also be hosted up by a cloud system. So what that means is that all our trifecta here, it just requires a lot less. So let's take a look at a case study. This is a real-life example of a client that I've had. And we started out with an on-premise solution that required 5 full-time people just to maintain. I'm not even talking about analysts here. I'm talking about getting the data from wherever it was coming from and loading it into the system, and making sure the systems are up and running, and while people are querying it, it was performance, all those kind of things. For a new data set or a new implementation here, a new data mart or something like that, a new project, it was about 3 months, which is pretty good. They had kind of streamlined their data pipeline, and they had really set everything up. So, 3 months was people were pretty happy with that. And the software licensing alone was greater than $150K a year. Some vendors out there on the data warehousing space charge 10 or 15K per terabyte. And in this company, we were an internet company, so we had 5+ petabytes in a Hadoop cluster. And in our data warehousing, our platform, we were about 15 terabytes. So 10K a terabyte, 150K a year, not including the 5 people and all the other costs of hosting it in the data center, just software licensing alone. When we did a comparison and we did a migration to the cloud, we actually were able to reduce that down to 1 FTE. And knowing how hard it is to find these people, it's not like we went and fired 4 of them. We basically now we're 5 times more productive. We were able to repurpose those other people and to have them do many more projects and really handle a lot of the additional needs that had been kind of sitting in the backlog for years. And we could deploy a new data set in about 2 weeks. There wasn't, because of the way the cloud worked, there weren't a lot of the setup steps that were required with our on-premise solution. So we wouldn't have to provision new servers and order them and put them in the rack and network them and do all that before we could use them. It was merely a couple clicks of a button and we'd be up and running. And the cost was extremely cheap. And this is not an exaggeration. These are real numbers. And people did not believe that this was possible and it would still be a performance system. So what I'm actually going to show you in a minute here is a demo of this setup that we went with here. Let me shift gears and let's talk about the types of vendors that you'll come across in this space. This is probably one of the hottest spaces right now, and every day I get emails from new, little startups with their BI platform in the cloud that's going to change the world. Well, I've looked at a lot of them, and I'm going to try to give you my take on the different classes of them. So if we think about where they are in the space, we have either our data warehouse as a service or our BI as a service. You're either doing the data side or you're kind of on the output side on the front end. From the BI as a service, I think there's a couple different classes or categories of people. You have your basic charting. And these are 5 vendors that I've looked at somewhat closely or even demoed and implemented in some cases. And I consider them to be able to do basic charting. And what I mean by that is Gecko Board, for example, if I wanted to see tweets about my company, I can log in and I can connect and I can give it my Twitter handle or whatever and create an API connection. And it will then pull in data and give me a canned set of reports. Chartio, Data Hero, similar. Domo and Burst are a little bit more in what I would call BI as a service. They're trying to grow into that space where you can actually do analysis and have a lot of control. But from my experience, it's still very much like that. You basically connect to some other cloud-based data sources, and it gives you canned reporting options. There isn't a lot of flexibility to really do analysis. From the BI as a service, these are the ones that are basically in the same space, but I think they're just a bit more mature. And no surprise here, a lot of these are kind of the big dogs in the industry that have been around for a long time anyways. So a lot of these companies, what they're doing, a lot of the traditional vendors like the MicroStrategy and information builders, they basically take what they've been doing on-premise for so many years, and they're converting it to be a cloud-based option. And in some cases, it's working really well. When I get into our demo, we're going to be looking at Tableau software and the Tableau Online implementation, which is just like their on-premise solution, just hosted by them. So a lot of these guys, it's much easier to really make a big splash in this space because they have all the really good software and engines that they've been building for years and years, and now they're just able to host it up online so you don't have to deal with that cost or that maintenance headache. On the other side, you have the data warehouse as a service, so the places where you can actually house your data. There's only two that I really have come across in this space, and that's Amazon and Google. No surprises there. Amazon Redshift is a columnar data store in the cloud, and you can connect it with your VPC. So if you have a bunch of stuff already running in Amazon, it can make a whole lot of sense to use Redshift as kind of the data warehouse. It handles data very well. It's a MPP type system, which is the massively parallel processing, so it can spread queries across many nodes. They all have this shared nothing architecture. It's a really robust kind of solution. The only downfall I would say about this one is that you still have to really maintain it. You still have to set up servers and connect it to your VPC. You still have to maintain the data sources in the system, so you have to perform maintenance on it and all that. It just saves you the act of actually having to stand it up and install some other similar software like Vertica or something yourself. Google BigQuery, on the other hand, is more of an actual service where you give it your data and all the maintenance and administration and headache of how many servers do I need to host this up and keep it performing well, and where did those servers need to be located, all that's handled for you by BigQuery. And from my experience, the performance on BigQuery has been tremendous. And we'll actually take a look at that in a few moments here when I get into a demo. There's another class that I just want to mention. I didn't put it on the diagram, but it's basically infrastructure as a service. And it's the two big players we already looked at, Amazon and Google, and I threw in Microsoft here as well. Microsoft is really making a push in this space. With Azure, they finally have the ability to host your own machines up there, and I believe I saw that you can host Linux machines as well. So as you guys probably are well aware, when you get into the big data space, almost all the platforms are Linux-based. So that has been one of the big limitations for the Microsoft stuff for a long time. So it's good to see them heading in that direction and being more flexible from a cloud or infrastructure as a service. Similar with Amazon and Google, you can basically spin up your own nodes. So if you have an on-premise system that doesn't, have a cloud option, or you don't want to use the, supported cloud option, for example, you could still do that same stuff in the cloud just using one of these platforms. And it basically takes away the work you need to do if you need to provision new servers or add storage or add memory, something like that. So this is a really great option where you can still increase your deployment time tremendously. If you need a new server, for example, on Amazon EC2, I've never seen it take more than an hour to spin up a new machine. And we're talking big, high-quality hardware that will actually perform well in your cluster. So looking at the overview of the services, we kind of have these three areas. We have the BI area, which talks about our acquisition of data, cleansing of data, analyzing it, presenting it. We have our virtual servers and hosting with the infrastructure side. And then we have our data warehousing side. So these guys are focused primarily on just data storage and query access. So now I want to take a look, and let's go into a demo of Google BigQuery and Tableau software. What I've done for this is I've actually created a new Gmail account, and I went and created a Tableau Online environment. So if I go to tableausoftware.com And on the bottom here, I see an option for analytics in the cloud. The way Tableau works is you have basically your desktop tools where you build things, and then you share them on either Tableau Server for an on-premise installation or Tableau Online for the cloud-based option. So if I go here and I click Analytics in the Cloud, I can say try it for free, and I can fill out my information. And it takes a couple hours or maybe an hour, hour and a half, and you'll get an email looking like this here. I think it went under promotions. Yep, and it says, welcome to your Tableau Online environment. Go ahead and click here, create your site, and you'll be up and running with their Tableau Server implementation all on the web. So this one runs $500 per person per year. So depending on the size of your implementation, it may be more advantageous to go with the Tableau Server route, which costs more, but depending on how many users you have. If you have 500 users or 1,000 users, it doesn't make sense to pay $500K a year for this when you could get that same level of service for much cheaper by buying the Tableau Server instance. So, but for this, we're going to look at Tableau Online, and if I were to go log into that right now, the URL is always going to be online.tableausoftware.com. Assuming that it works. And while we wait for that, I can show you also what I did for this example is I created a BigQuery implementation. And with Google BigQuery, the way that works is it's basically just a part of your Google account. So if you have a Google Apps for Business, this will just be another added service in that. To go there, we go to the Google Developers Console. Or let me just actually go here and show you. So the way I always find this is I go here and search for it. And with BigQuery, what you can do is you can sign up, for a Google account if you don't already have one, and then you go into the Developers Console and create a project. So with this, I created a simple Cloud BI webinar project. I actually didn't have to do that because there's a public one that we're actually going to use for this demo. But if you were doing it for real, in your environment, you'd click on that, and then you'd go through a process of creating a storage bucket, uploading some data to it, and importing that data into BigQuery. In a real production environment, what you probably would want to do is have a streaming setup. So basically, it would be as data is flowing in, it would be all automatically flowing into your Google storage bucket, and then you could be populating it into BigQuery. If you already have a Google account and you already have a project, you should be able, you probably have already seen this, where you just say, try BigQuery, and it'll load it up for you. If you don't have that and you're wondering how do I get there, under APIs and Auth, I click on APIs, and it'll be the top one here, the Google BigQuery API. So if this were off, I would just click on, and then I'm ready to start using it. So in Google BigQuery, I get a web-based query interface as well as a REST API that I can use to build applications on, as well as there's a lot of native APIs for a lot of different languages. It's really well supported. So if I just wanted to go in here and say compose a query, you can see some of the ones that I've done in the past. I actually have one that I'm going to paste in from an example. So this understands regular old SQL, and we're going to look at this public data here, and we're going to look at the natality data set. So first, actually, let me just do this. Let me just create a simple query to figure out how many rows we have, so you can see how much data we're actually looking at. So there you go. We have about 137 million rows of data, and what that take 3.2 seconds to do a simple query on it. Of course, you guys probably know that those simple queries can often be fast, especially if they're cached. Here I'm going to do one that's a bit more complex. I have the year, and I'm going to get the average weight in pounds. This data set, what it represents, if I click on it, I can see the metadata for it. In here, it's basically all the stats about babies being born since 1966 or 69, I believe, to today. So if I want to analyze this, there's 137 million rows. I click Run Query. And the way you pay for Google BigQuery is you pay for how much data you store as well as how much data you process or how much data you query. So the storage, if you look up Google BigQuery pricing, I think is about 2.5 cents a month per gigabyte. and you actually get a free terabyte worth of querying every month. And so beyond that, it's something like 5 cents or 0.5 cents per gigabyte queried. So if you did the math on that and you looked at, let's say you have a 500 gigabyte data warehouse and you wanted to pay for storage, and let's assume that you queried the entire database every single day, all 500 gigabytes, for 365 days in a row, you'd be just at about $1,000 for a 500 gigabyte data warehouse with that kind of storage and performance. And like I said, unlike Amazon, I don't actually manage servers in this case. I basically give it my data and it handles all of that for me. So it does the geolocation. If I'm hammering the data set, it'll spin up additional servers to make sure that the queries are still performant. And you can see what it did here. So it ran in 4 seconds. It scanned 2 gigabytes worth of data, and 140 million rows. And it gave me of this 40 rows here. So 1969, you can see what the average weight was all the way going forward. So I can save this query, I can save this view, I can have it create a new table based on it. It really is a pretty robust interface, and it understands ANSI SQL. So if you guys know SQL, this will be a pretty easy tool to pick up. It's not like a different language you have to learn. So now let me jump back over to Tableau Online. It looks like it finally loaded there. And I'm going to log in, if I can remember what it is. Repeat and copy paste. Cool. So when you log into Tableau Online, you get this video here, and it can walk you through and tell you what's going on. But that's what I'm here for. So I can kind of do that for you. You have here in the Tableau Online environment different projects you can create. Project is kind of like a folder. Inside of a project, you have workbooks. Workbooks are a lot like Excel workbooks, where inside of a workbook, if I click on Variety, for example, I have lots of different views. And a view could be a dashboard, which is like a collection of charts, or it could be a single chart itself. It just depends whatever you want to make it. So this stuff is all living. I'm not hosting this. I'm paying $500 per year per person that has access to this. I want to share data with partners, for example, and I don't have an external-facing interface, external-facing BI platform where I can publish things. I can spin this up as an experiment and do that kind of thing. I can go into the admin section and I can look at site activity, user activity, all this jazz. I can set up projects and security groups. I can import users, all this jazz. So it's a pretty complete, robust solution. Now let me show you how these two can work together. I'm going to open Tableau Desktop, and I'm running Tableau on the Mac here. It works almost identically in the Windows version. So if I'm in Tableau Desktop and I click Connect to Data, I'll choose Google BigQuery as my data source. I'll log in. And now it's going to ask me to select a project. There's my Cloud BI webinar project, which doesn't have any data in it, so I won't use it. But just for illustration purposes, as you create these projects, that's how you'll identify where to get the data. I'll click the public data one, and we have a samples data set. And notice on here, I have all those same tables of data that I had in my developer console down here. So that's where Tableau is getting that metadata from. We're going to take a look at the natality data set. I'm just going to go ahead and drag that over to my data connection window here. As it does that, it just read the metadata from it. I can click Update Now. It'll go get a sample of the data set so I can actually see the data that I'm working with before I go into Tableau to analyze it. I can just kind of scroll around the data set, see if there's any funky business going on. I just get a nice preview of it here. Okay, now I'll click Go to Worksheet. And here what I wanted to do is I wanted to create a dashboard. So let's take a look and see what we can come up with. Now Tableau, if you're unfamiliar with it, automatically categorizes data by dimensions and measures on the left side. And in here, it guesses which ones are dimensions, which ones are measures. It doesn't always get it right. So for example, father age, I may want to make that a dimension, so I can group and sort and filter by it. So I just drag it up there and it does that automatically for me. So when I'm doing this, I'm working with a metadata layer in Tableau. I'm not actually affecting the source system. So Tableau has its own metadata that I'm creating of my data set here. So if I wanted to do something simple, like let's drag year over and take a look at year across time, and we'll take weight in pounds, drag that over. I can see a sum of weight in pounds, which could be affected by the number of babies being born. So instead, let's change that to an average. So I'm changing my aggregation to an average. If you guys are familiar with working with OLAP technologies in the past, that right there is probably pretty amazing. I know I was pretty shocked when I was able to just on the fly change an aggregation. And what I've seen here is it really is all pretty similar, right? It's all right around that 7-pound mark. So let's see a more interesting view. First, let's change this to a bar chart. No story being told yet. What if instead of looking at just the number over time, I added a calculation which showed me a % difference year over year? Now I'm getting more of a story here. I'm going to hold Command on my keyboard and copy or click and drag this onto color, and now I'm getting even a better picture of what's happened over time. I can click on this and change the color scheme if I want to, but let's go ahead and leave that there. Let's assume nobody's colorblind and they can tell the difference between green and red. So we'll call this time series. Let's go ahead and take another one and see where the fattest babies are coming from. I'm in California, so I'm hoping it's not California, but maybe it's a good thing and maybe it's somewhere else. So let's see. So if I were to just double-click state, it automatically drew a map for me. And if I wanted to see weight in pounds, I'll drag that onto color. Automatically colors it. Let's do what we did before, change it to an average. And something that's happening behind the scenes here that maybe is transparent, hopefully transparent, is notice every time I drag a field on and change the aggregation type or create a calculation based on it, Tableau, in this case, on my desktop, is connecting out to Google BigQuery, getting the data. It's going to cache as much of it as it can, so that's how the performance will increase the more you use it. But then it's also going to perform these calculations in memory and draw the associated images using color, shape, size, whatever. Now if I wanted to make this to something more interesting, let's say orange, white, diverging, I can see this kind of here, and maybe this is color scheme. I want to see it reversed. So the redder you are, or the more orangish brown, I guess, the fatter the babies you're producing. So we can kind of see it. It looks a little bit like Alaska is doing the heaviest lifting here. Let's call this one a map. I'm going to go ahead and create another one and call this bar. And we'll do the same analysis to see if it's actually true or not. Does Alaska produce the fattest babies on average? Changes to an average. Notice how it's getting much faster because it's caching all the data. And it, in fact, does look like they do. Let's add some row labels here. Format this guy. Oh, that's not the one I wanted. This is the one I wanted. There you go. Get rid of this so we can kind of show that. All right, now let's create a dashboard. So I have 3 charts here. I'm just going to go ahead and double-click each one and see what Tableau gives me. Let's do something like that. Let's make this guy floating. If you guys have done Tableau work before, you'll notice that where you spend the majority of your time is in formatting. There we go. Okay, let's say that this is good enough. Or actually, let's do this. Let's switch these around. Let's have this one go up here, and let's put this guy down below. I don't think I can reach that. Let me change the layout here. Let's make it friendly for an iPad. We want Apple to have higher revenues, so let's do that. Let's encourage the use of iPads. All right, so getting there. So now I have something interesting. I have 3 different charts, all from the same data set. Each one of these is pulling data from Google BigQuery. I'm going to go ahead and save this. And let's do something fun. Let's say that we want people to be able to click a couple of these charts and have it filter the rest of them. We'll do something like this. I'll say use as a filter. So here I can actually say, okay, let's take a look at what's going on the west coast of America. And when I highlight that, it filtered the rest of the data down to what I selected. And the reason I'm showing that is I know it's more of a tablet desktop feature, but just think about what's happening behind the scenes. It's going to Google BigQuery, coming up with those aggregations, filtering the data set down, and doing that all in fractions of a second. So the thing to take away from this is that Google BigQuery is fast. It works really, really well. And now let's say that I wanted to share this. So I've come up with some analysis. I found out that the fattest babies come from Alaska. Don't know why, but they do. And then I can kind of sort and filter and play with my data and do all that. Let's say make this one as a filter as well. Now it's time to share this out. This is where the cloud aspect is really valuable. So I'll save this first. I'll hit server and publish workbook. And I'm going to punch in online.tablowsoftware.com. So if you had an on-premise solution, you'd punch in whatever that address was or IP or however you set it up internally. Here you're going to punch in the same one that I logged into it with the web. Give it my password. And now from an enterprise standpoint, Tableau offers permissions and permissions based on projects and groups. So it's multi-layered, more like a parfait, less like an onion. And with that, when I change the project, which I'm not able to do because I only have one, it'll actually reset the permissions, and the permissions can get very granular. So I can say, okay, all users can view, they can do web edit, inherit that or deny it, etc. I can say download the data or don't download the data, whatever. I can get very kind of specific about how I want people to be able to consume this dashboard. So let's assume that we're fine with the default it gives us. We can have users need to log in when they view this. So if you had something that was maybe role-based or required to log in, and based on that login, the different data would be returned, like a row-level security, you can do so using this. I prefer another method where I actually embed any row-level security into my data source connection, and then I embed the password, the authentication itself. That way, we don't have to manage users in 5 different places. We only have to manage them. If you can see this dashboard, then the data connection also works for you. That's my preference on how to do it. And if you wanted to do row-level security that way, there's ways to do it in Tableau. So, okay, let's assume that we're done here. Let's assume that we've got, we've named it, we've tagged it, webinar, Pluralsight, Cloud, BI, whatever. We created tags, we chose what we want to share. We click publish. It's going to take the data source here, and it's going to take basically that connection to it. It's going to take the dashboard, all the metadata I've created. I could have went in and created calculations like average cigarettes per pound or something like that. There are all kinds of like stats in there about that. If I could come up with metadata and share that on the web here. It's going to then render this here. This sometimes doesn't work, so I'll just jump over to the website itself. Oh, there it goes. And so back in Tableau on my site that I created, I'm going to go ahead and just refresh this. Just click on the icon, and I can sort this by modified. And you can see there's dashboard 1, the one I just created. And so when I'm loading this on the web for the first time, it's going to have to do that same thing. It's going to have to go out to Google BigQuery, scan 140 million rows, sort, create the calculations, create everything I did, render the images, color code them properly, get the map, put all the colors on the map, and make it all fit perfectly in the dimensions that I gave it. Then from here, I can do that exact same type of interaction. Let's say I wanted to see what's going on in the Northeast. It's colder, maybe their babies are fatter there for some reason, I don't know. I highlight that, and without even making a single click, all the other two updated. And as I do that more and more, things are going to get cached on the Tableau server, and it's just going to get faster and faster. So that's end-to-end a way that you can have data living in Google BigQuery, sizable amount of data. It handles, as it advertises, up to petabytes. The largest implementation I've done in Google BigQuery is close to 15 terabytes. And then Tableau, being able to connect directly to it, you can spin up a Tableau server where you can share this with other people and you can do all kinds of analysis. It has a lot of the enterprise features that you may want as well. So let's say that, for example, I was looking at this subset of states, and like I said, notice how it's getting faster. I can say, remember my changes, and say, West Coast, babies, remember, and it'll actually give me a separate URL with the name I just gave it, and I could email this to somebody. So I can create one chart that maybe is kind of generic, and then it allows people to sort, filter, give it their own custom name and own link, and then they can even subscribe to that via email. So if I wanted to have a comment discussion down on the bottom, I can do that. I can do all these kind of things. This whole environment was spun up just by submitting an online form and having them do it all for you. If I wanted to do this similar thing, the best, but on premise, the best bet I think would be to do it more with an EC2, an infrastructure as a service component like Amazon. And then you at least could spin up the servers very quickly and go through the install process. But then if you wanted to just do it out of the box, what we just showed you here how to do to get this kind of performance, this kind of flexibility would take weeks at least. Even if you had the server already sitting in the data center, you may have an issue with the power supply, may not fit in the rack, all these kind of other things can pop up, and the cloud just wipes all that away. It truly allows you to focus directly on value, on delivering, answering those questions that span all these different areas, and doing what BI was meant to be doing in the first place. Now let's wrap up here. I'm going to jump back over to my presentation, and then we'll kind of open it up for questions. So we started out asking, should you make the jump? I went through some examples, some case studies, some classifications of different vendors, and showing you a demo of that. Let's talk about pros and cons. I'll start with the cons. One are the security concerns, and these are legit. It's no doubt a lot of industries, highly regulated ones, have serious security concerns about data and putting data into a third-party system that lives like a Google BigQuery or an Amazon instance. I would say that you can mitigate a lot of that by removing a lot of the unnecessary PII or any of the other very sensitive information. For example, at one client I was at, instead of uploading the username, which is required to get a unique user count that we're consuming some content, instead what we did is down on our on-premise system, we converted the username to a randomly generated number. And we have one table and one database on-premise that is secured behind our firewall with all those kind of normal security controls that made no sense but gave us a unique ID, so then we could do the analytics on it. So there are ways to obfuscate and change your data to where even if it did fall into the wrong hands, it really would be kind of meaningless. They may be able to glean some aggregate information from it, but it wouldn't necessarily be personal or any kind of major leak like that. So you can mitigate that and you can control it. Movement is another one. How do we actually get data to the cloud? Sometimes if you do just only batch-oriented updates, and you're having, I don't know, if you're like Facebook and you have 350 million cat photos uploaded every day, putting all that data up into a different system, meaning you're going to probably transfer it over HTTP over the web. Imagine how long it takes to upload a 10 gig file. Well, if we're trying to upload terabytes of data a day, that could be an issue. There are ways to work around that. As I mentioned earlier, streaming. So you're actually uploading the data in little tiny bits as it's coming in, if that's possible. Enterprise integration, these systems, like Tableau Online, for example, you have to have a separate username and password. It doesn't integrate with Active Directory or any of the other, SAML type things. It doesn't mean that they won't be working in that direction, but that could be a concern. And looking at the pros, though, we have a cost savings of 80 or more %. Huge, huge. I don't know, budgets I've seen in the past, IT budgets can range, 10 to 20% of the company's overall budget. BI can be a big chunk of that. Imagine if you could save 80% on that cost. Meanwhile, you're able to deliver things faster. The stuff we just showed you, I set up in a couple hours prior to the call. It really is that easy to get up and running. Also, when we can have this flexibility of spinning up new machines, spinning down things that we don't need anymore, you have really total control over it without all the traditional kind of red tape or heavy lifting that requires a lot of these changes. It also reduces the amount of maintenance. Google BigQuery, for example, you give it your data and you're done. You don't have to manage the servers. You don't have to maintain it. Some of the other ones you do, but there's still a lot of stuff that just goes away. Even if you're using infrastructure as a service, where you're basically doing on-premise stuff just up there in an Amazon or Google environment, you still don't have to maintain the actual physical machines. They handle all that for you, so it helps in that regard as well. And also, you get greater performance. That example I showed you there, I don't know if you guys have done similar examples, but I know I've tried to do one where I took that exact same data set and loaded an on-premise SQL Server instance running entirely on solid-state drives, and doing those exact same things, it was significantly slower. So you can get a lot more performance for a lot less money, which kind of sounds too good to be true, which is why I kind of wanted to call out the concerns as well, because there is no perfect solution here, but this one in my mind is definitely worth a try. And that's my last bit of advice, is to experiment. Don't go head over heels in this and just think we're going to throw out all the work we've done internally and all that we spent millions of dollars on years. Do an experiment. Find a small enough data set and maybe a single use case or a couple set of use cases. Like I said, I spun everything you saw today up in a couple hours, so it wouldn't be hard to, if you've had that good use case, to just spin this up, spend a couple of bucks, see if it's going to work for you. I hope that you do that and, in the process learn whether or not this would fit into your environment, because if so, I think there could be great benefits to glean from it. And with that, I think we got some minutes here. We'll open it up for questions. Looks like we have a question here from Nathan. We'll go with that one. Do the data warehouse as a service vendors still allow full control of dimensional data model? I think it depends which one you pick. Nathan, I would take a look at some of these and how they are structured is quite different. So, for example, in Google BigQuery, it has a columnar storage engine, which means that you don't necessarily need to have separate tables for every dimension. In fact, I have an article on my blog where I propose this new concept of actually, with columnar engine specifically, flattening the data, the stars, into a single wide table, because you don't lose any performance by doing so, but you reduce the need to actually have multiple joins in your query. And so remember, the idea of a Kimball model was to simplify access. That's why we created star schemas. So imagine if you could actually collapse that star into a single table. An analyst or somebody never has to actually do a separate join. Now you may be thinking, yeah, there's more complex relationships than that. Absolutely, not every case is going to be that. But if you wanted to have separate tables for each different thing, for each different dimension, basically have your star replicated up in a BigQuery, you can totally do that. It just may not be as efficient as you'd think, because querying one table in Google BigQuery is a bit more efficient. Querying one giant table is a bit more efficient than doing a join between a couple small tables. So depending on which one you look at, you should have full control over that, but just make sure that you're, do some testing, do some experimentation. And Nathan, it looks like you also asked about ETL. Yeah, you're absolutely right. ETL is a big cost, and it certainly is one of the challenges. I mean, it doesn't go away in this instance. I propose a different approach with this, especially if you're in the big data world, where you can kind of land all of your data in something like a Hadoop that doesn't care about a schema, and then from there build ETL processes to just tease out the bits into the normalized or the denormalized star schemas that you want. So yeah, depending. Redshift is a bit better at this. There's, I think, SyncSort is a company that has something called Ironworks, where it will allow you to basically do this thing where you store your raw data in a Hadoop instance on EC2, and then it will allow you to run ETL in that environment to land the data into Redshift. So I think vendors are going this route because they realize that as you know, the cost of doing this stuff is so great on premise that a lot of people are doing it in the cloud now, and it really would be a pain to try to, you know, land all of your data in a Elastic MapReduce instance on Amazon, download it, modify it, clean it up, and then upload it back to Redshift. So vendors are doing that. The only one that comes to mind is SyncSort with their, I think it's called Ironworks or something like that. So, all right, let me go down here. Can we also connect BigQuery with OLAP in a similar way? I'm not sure I understand the question totally. BigQuery is the data warehouse. So if you wanted to, I guess, pull data out of BigQuery into an OLAP cube, yeah, it has a REST API and it has all that kind of stuff. So it's certainly possible. I'm not sure I'd recommend it. I think just connecting to BigQuery directly will probably give you better performance depending on the types of analysis you're doing. It's certainly more flexible. So I probably wouldn't do it that way, but probably possible. Okay. Got a question from Aaron. Would be curious to see how much of a tab we run up on Google BigQuery through this example. Great question. I can actually show you that. So go back, I think it's under overview. Yeah, estimated charges this month. So since I've built this up and have been testing, I've racked up exactly $0. You have, first off, I've been using the sample data set, so that's free to store on that. And you have 1 terabyte worth of free querying per month. So I can tell you though, from a real live example, we use Google BigQuery at Pluralsight, and last month our bill for storage, and we have our largest data set up there, which isn't very large. That cost about 45 cents for hosting last month, and of all the querying, I think we had, if I recall correctly, like 5,000 plus queries that were ran against it. I think the total charge, because we have the free usage tier of 1 terabyte, the charge after that was like 23 cents or something. So so under $1. Like I said, imagine if you had a 500 gigabyte data warehouse and you had that entire thing living in BigQuery, and you queried 100% of it every single day for 365 days. The bill at the end of the year is estimated around $1,000. So it is extremely cheap. And in fact, I'll just pull that up for you right now so you guys can see this. So there's free operations like loading data, exporting data, table reads, copying data. Storage is 0.0, so 2.6 cents per month per gigabyte. You can do the streaming inserts. So as I mentioned, as you know, kind of the real-time analytics, you can have that going in, and that's free to do that. Queries are, there you go, $5 per terabyte. And you can also do a reserved capacity pricing if you know you have just a mountain of data and a mountain of querying. You can do that with a a pricing model like this. This is like if you're building an application that has millions of users. If you're just doing it for the typical analytics side of it, I wouldn't do a reserved at all. And so it has all these calculators and stuff about how to cache. Also, it's columnar, so if I have 100 columns in my data set and I query 2 of them, it's only going to scan those 2 columns. So I won't be charged for scanning the entire data set. So even if it's a 5 terabyte data set, it may only scan a fraction of the actual size of it. So it's pretty good about how it does that. All right, let's see. Is Google BigQuery Amazon valid for health-related data? Do economics of the solution change drastically? I'm not sure what you mean by the economics of the solution. If you're talking about the cost of storing it, I don't think that matters. The only thing with health-related data that I would think about here primarily is all the regulations that you have around how to handle the data and what you can actually do with it. I know I've worked in that space before, and it's not simple and not easy. So I have went through security audits with Redshift and BigQuery and Tableau Online at different clients, and it's passed with flying colors. But I would encourage you to do that. Don't take my word for it. Definitely make sure you do a full security audit in regards to that. Best practices for uploading data to BigQuery. Well, the first step is you have to put it into a Google storage bucket. So you have to land it on Google somehow, and then you flow it over into BigQuery. My recommendation would be to go land it in Hadoop as much as possible, land it on a Google Hadoop instance if you're using Hadoop, and then you can stream it into BigQuery real time. Guaranteed SLAs on these vendors. Mark, that's a great question. It depends on what kind of SLAs you're talking about. If you're going the route and you want to have, you're looking at a big time contract with these guys, I recommend just reaching out to them. If you're looking at like the enterprise space and you're not just doing kind of small experimentation, each one of these companies, they have they have people that are designed there to help you through all that. So I'm sure they could answer your questions better. I've not come across that. Do you think Microsoft will be good enough contender in the BI space? Oh, this is such a contentious question for me. I used to be a Microsoft BI consultant. Is it good enough contender in the BI space? Well, it's the worst answer. It depends. If you're a smaller shop and you guys have a lot of Microsoft tools, and by smaller I mean you're not talking about terabytes and terabytes of data in your data warehouse, then yeah, I think it's great. I think SQL Server is an excellent database. I think the other BI tools leave a bit to be desired, but if you're getting licenses for them without having to pay for it, meaning you pay for SQL Server and you automatically get it, and I think they came out with a new BI-only version, I think it's viable. Yeah, I think it depends. If you're in the kind of big data space, I don't think Microsoft really has an answer for that yet. They might be working on something. I know that there's a way to run SQL Server on top of HDFS or something, but for most of the bigger implementations, I would say it doesn't work. And as far as for the front end, I don't think they have a solution. I know Power View is decent, but I think it's similar. It's almost like a Tableau clone, similar to MicroStrategy's what's it called, Wisdom or whatever their system is called. A lot of people are just trying to keep up with Tableau on the actual BI space. From the data warehousing space, I think there's a lot of options there, but Microsoft can be a decent one. Without the need to install SharePoint. Amen. Yeah. I would hope that your BI implementation doesn't require you to install SharePoint. To me, that wouldn't make sense at all. From an end-to-end perspective, do I need to rewrite all ETL, staging transformations, SQL, SSIS, SSAX queues in order to move to the cloud? No. Microsoft, I think, is offering their infrastructure as a service. So if your pain point is hosting and getting new servers stood up and managing the infrastructure, you should be able to leverage Azure pretty well with that. If you were going one of these other routes, Google BigQuery or Amazon Redshift, and you already have all this, you wouldn't have to rewrite all of it. In fact, we, like at Pluralsight, we have SQL Server, and we use that for a lot of our stuff prior to the front end. We kind of use Google BigQuery as our forward-facing to all of our analysts. So if you think about it, the goal of data warehousing, of data marts and star schemas and stuff was to simplify it. Well, with a cube and with a complex star schema, it still is pretty tough. You still have to be a pretty strong analyst. So instead, what I would recommend is keeping all that stuff in place, and then when you come time to create the data set that people are going to query, flatten it out and put it into something like BigQuery or Redshift. If you go to my blog on bensullins.com, I have something on there called the Pulsar method, and it's something I recommend for doing and that specifically answers that question. So you can keep a lot of what you've done and just kind of extend it and make kind of the front end, bigger and better. Do I use tools for sentiment analysis? I personally do not. We have some data scientists that use R, I know of, and R, has plugins to a lot of these things. So that's the one I would recommend. Is it possible to integrate Cloud BI into client web apps? Absolutely. Yeah, I mean, that's part of the beauty of these things is they have a REST, or Google BigQuery specifically has a REST API, as well as native APIs in a lot of different languages. So if you wanted to integrate this and, put it in your app somewhere, some client dashboard or something, this is totally an option for you. And Google BigQuery, for example, uses OAuth 2.0. So you can integrate it with your authentication protocol just using those protocols. Joe Meng asks, you spoke of security in terms of protecting PII data. How would you protect intellectual property data? I'm asking about data that if the competitor acquired it would devastate your company. Yeah, that's a great question, Joe. Go through a complete security audit of these guys before you decide to put that data up there. I've done it in the past, and every time I've done it, it turns out that they're doing a heck of a job in terms of securing stuff and making sure it's valid. So yeah, but don't take my word for it. Definitely make sure that you're comfortable with it before you put that kind of data up there. But once you get that good comfort level with it and that trust level, I think you'd be surprised at how much value it can bring. Anu, I won't try to pronounce your last name, asks, can I use basically the Microsoft BI stack in the cloud? I can only do BI using the Microsoft stack. Yeah, like I said, Microsoft offers some form of the infrastructure as a service with Azure, so you should be able to do that with them. And if you want to look at these other ones, some of them integrate well. So Tableau, for example, can pull from OLAP queues and all that stuff if you want to use Tableau as a front end on top of your Microsoft stack. What tools does the end user have to manipulate the data? For example, are there any capabilities such as Power View, Power Query? Okay. We only have a couple minutes left, but I'll show you that example right here. So imagine I'm the user and I'm looking at this, and you saw how I could actually customize my view. Well, what if I wanted to completely change this or create a new view? Tableau Online gives you the ability to click Edit, and what you'll get is a web interface to edit your data that looks identical to the desktop environment. So let's say in here, I have this and it's average weight in pounds. What if instead I wanted to change that by, I don't know, mother age or something like that? I can actually manipulate this view, change it to be whatever I want, save it again and overwrite what was there, or I could save it as a new one. So I've actually taught entire classes on using Tableau's web. Looks like there's a data source there. Tableau's web interface. So with that, you have the ability to manipulate the views just as you would if you were in Tableau Desktop. There are some limitations, however, and I don't know what's going on with that error, but yeah, there's totally options in that space. How does BigQuery differ from Hadoop? Great question. I would say it's vastly different. Hadoop is a distributed computing platform that allows you to do a vast amount of things and store unlimited amounts of data seemingly. BigQuery is designed for analytics. So its focus is much narrower than Hadoop is. Hadoop certainly wouldn't give you the query performance that BigQuery does. And so, I mean, there's other ways to make Hadoop become a BigQuery or a analytics platform, things like Impala, Shark, all those. So anyways, that's one of the differences there. So it's more narrowly focused and more tailored for analytics specifically. Okay, I don't think we have any more questions, at least not in the thing here. Lindsay, is there anything else? Or if not, I thank you guys all for joining.